So number 4 says draw the Lewis structure for a stable covalently bonded molecule. And if it's an exception to the octet rule, the question is going to say, just like it did on your quiz, draw the following structure and tell why it's an exception to the octet rule. Okay? But most of the compounds that you'll see on your test tomorrow are going to be just stable, octet obeying compounds. So how do you draw the correct structure anytime? Well, it goes back to that first example we did. Count up your valence electrons. So oxygen has, there's 3 oxygen, each with 6 electrons. I've got 16 electrons to get all 3 oxygen stable. So put 1 oxygen in the middle, attach the other 2 with single bonds, and see if you have enough electrons to get all 3 atoms happy. So the 2 oxygens on the end each needs 6 more. The one in the middle needs 4 more. And if I count up, that's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So the -2 tells you what? Yeah, form a double bond somewhere. So if I form a double bond right here, then I don't need that lone pair, and I don't need that lone pair. Sharing 1 pair takes a lone pair off of each of the atoms sharing. That's why you save 2 electrons. Because now my left-hand oxygen here has 2, 4, 6, 8. The middle oxygen has 10, 12, and then 14, 16, 18. That's my correct structure, O3. Okay, this is key that you're able to draw these, because if you can't draw these, you wouldn't know that O3 has a bent shape. Okay, if you don't know it has a bent shape, then you wouldn't know a lot of other properties about it that we'll be studying the rest of Try 2 and Try 3. So see what you can do with CH2O and SiO2 following that same format. Total valence electrons, single bonds first, and then if you need to, put some double bonds in. Okay, so if we look at these other 2 molecules, nothing real unusual with them. I've got 4 electrons for carbon. I've got 1 in each hydrogen for a total of 2. I've got 6 in oxygen, so that's 12 electrons. So I put carbon in the middle. Remember, if hydrogen happens to be listed first, hydrogen can never go in the middle. Hydrogen can only make 1 bond because it only has that 1 orbital, the 1 electron. So I go ahead and put it on. So that means each hydrogen is good with just its single bond. Carbon needs another pair. Oxygen needs 3 more pairs, 6 more electrons. So now I've used 2, 4, 6, 8, 10, 12, 14. So the 2 electrons lets me know I need a double bond. What's the only place the double bond can go? On the carbon and oxygen, because we just said hydrogen's too little. So that means that lone pair and that lone pair come off. And then SiO2, is silicon got 4? Yeah, because it's in carbon's family. Oxygen each have 6, so 12, 16 electrons. I put Si in the middle, attach the oxygen, fill up the octet rule for each one. And with this one, I end up with 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So now that you're short 4 electrons, what does that tell you? 2 double bonds. Now, technically, you could put 1 triple bond and leave the other one a single bond, but that would not be balanced at all. Molecules always do whatever keeps it the most balanced. Think of it as a teeter-totter. You want to keep that teeter-totter as balanced as possible. So it's far more balanced to give each one a double bond. So then 1 lone pair comes off oxygen and silicon, and then another lone pair comes off silicon, off the other oxygen. And SiO2, you actually know that that's what's in glass, silicon dioxide. It's quartz, it's sand, it's all around you. Okay, questions on drawing it?